All right, welcome to the Explainer. When we're building these powerful AI systems, there's one decision that honestly trumps almost everything else. And it's something that sounds kind of boring: document chunking. But trust me, this one simple step, it literally sets the performance ceiling for everything that comes after.
So, here's the plan for today. First up, why is chunking such a bottleneck? Then we'll get into the great trade-off. The balancing act you're always playing. After that, we'll run through a whole spectrum of strategies, from the easy stuff to the really advanced. We'll even look at some next-level retrieval techniques. And of course, we gotta talk about how you actually put this into practice. Finally, we'll tackle the big question: does chunking even matter anymore with these huge AI models?
Okay, first things first. Let's really nail down why this one simple act, just splitting up your documents, has such a massive impact on the performance of any Retrieval-Augmented Generation or RAG system. It really does govern everything. So just to make sure we're all on the same page here, what is RAG? The best way to think about it is like giving an LLM an open book exam, right? Instead of just relying on whatever it crammed during its training, it gets to look things up in your documents in real time to find the answer. It's a total game changer.
And this leads right to that classic saying, garbage in, garbage out. And let me tell you, for RAG, this is gospel. The quality of the final answer is completely dependent on what you retrieve. If your system pulls up a chunk of text that's irrelevant, or worse, one that's been chopped off in the middle of a thought, well, the LLM is stuck. It has to try and build an answer on a broken foundation. And that's exactly how you end up with wrong answers, weird contradictions, or the model just given up.
So here's the key thing to remember. Anytime you chunk a document, you're basically doing a form of lossy compression. Think about it. A full document is this smooth, connected story. But the second we slice it up, we're cutting those invisible threads of context. A pronoun in one paragraph referring to something 3 paragraphs earlier, snap. A cause and effect relationship that builds over a page, dawn. So really, every single chunking strategy out there is just an attempt to do this slicing as carefully as possible to minimize how much important stuff we lose along the way. All right, now let's get into the real heart of the matter, the great trade-off. This is where things get tricky, because choosing a chunking strategy isn't about finding one perfect method that works for everything. No way. It's a constant balancing act between a bunch of goals that are all fighting against each other.
And the biggest trade-off of all? It really just comes down to size. Big chunks versus small chunks. On one hand, big chunks are great because they keep a ton of context, perfect for those complex summary-style questions. But the downside is that the one specific sentence you need might be buried in a sea of other text, just noise. It dilutes the signal. Then you've got small chunks. They're super precise, laser-focused, but they're risky. You might lose the crucial context you need. A small chunk might give you one sentence from a legal contract, but you completely miss the sentence right before it that defines a critical term. Ouch. And what's really cool is how this whole big versus small dilemma maps perfectly onto two classic ideas from the world of search: precision and recall. Precision is all about how relevant is the stuff we got back. Small, focused chunks usually nail this. But then there's recall, which asks, did we get all the relevant stuff? And that's where small chunks can fail you. You might get one perfectly relevant sentence, but you miss 2 other critical sentences from different parts of the document. So you have high precision, but terrible recall.
And we can't forget about the money and speed. This stuff has real-world consequences. If you go with smaller chunks, you're going to have more of them. That means higher storage costs, maybe more database lookups for every single query. But, and this is a big but, when it's time for the LLM to actually generate an answer, feeding it a few small, clean chunks is way faster and way cheaper on your API bill than trying to stuff a giant, messy block of text into the prompt.
Okay, so with all those trade-offs rattling around in our heads, let's open up the toolbox and see what strategies we actually have to work with. And it's a real spectrum, all the way from super simple, rule-based methods to some pretty sophisticated stuff that uses AI to understand what it's reading. So, on the simple end of the spectrum, you have heuristics. The most basic one is fixed-size chunking. It's pretty dumb. It just takes a giant pair of scissors and cuts the text every, say, 500 characters. It's fast, I'll give it that, but it has absolutely no idea what the words mean. It could take a sentence like, the system must not, under any circumstances, be turned off, and cut it right after the word not, completely flipping the meaning. Yikes. That's why a much better starting point for almost any project is something called recursive character splitting.
And the reason this one is so smart is because it has a hierarchy.
It's graceful. It starts by trying to keep things together that belong together. First, it'll try to split by paragraphs. If a paragraph is still too big, okay, fine. It'll then try splitting that paragraph into sentences. Still too big? Okay, then it'll go down to words. It's this beautiful cascading logic that fights as hard as it can to keep the meaningful chunks of your text intact. Now, if we level up a bit, we get some more advanced strategies. You've got structure-aware chunking, which is smart enough to look at the document's formatting. Like for a markdown file, it'll say, hey, here's a big heading. That's probably a new section. Let's make that a chunk. And then you have the really cutting-edge stuff, like semantic chunking. This is where you use another AI model to actually read the text and figure out where the topic changes. It creates these perfect little thematic packages of information. Pretty amazing.
Okay, now we're going to get into the really cool stuff. These are paradigms that go beyond just splitting documents. They're about intelligently structuring them to make the whole retrieval process way, way smarter.
And one of my absolute favorites is the small to big strategy. This is a total game changer because it elegantly solves that precision versus context problem we talked about. Here's how it works. You basically decouple what you search for from what you feed the LLM. You create these tiny, precise child chunks, maybe just single sentences, and you use those for your search. They're great for finding an exact match. But once you find the best child chunk, you don't send it to the model. Instead, you go and grab its larger parent chunk, the full paragraph it came from, and you send that instead. It's brilliant. You get the laser precision of small chunks for your search and the rich context of big chunks for your generation. Literally the best of both worlds.
Here's another really clever idea. Late chunking. Normally, you chop up the document first, and then you create a vector embedding for each little isolated piece. Late chunking flips that completely on its head. It creates a vector for the entire document first. What does that do? It means that the vector for a sentence at the very beginning of a book is now subtly aware of ideas that are mentioned in the final chapter. Every single chunk, no matter how small, carries a little bit of that global, whole document context with it. Super powerful. Okay, that was a ton of theory, I know. So the big question is, how do you actually choose? Which one of these is right for your project? Well, you need a framework for thinking about it.
So think of this matrix as your starting point, your cheat sheet. The most important thing you can do is think about the shape of the questions your users are going to ask. Are they going to be asking for tiny, specific facts? If so, you need to optimize for precision, which probably means smaller chunks. Or are they going to be asking for broad summaries, like, explain this concept to me? In that case, you need rich context, so you lean towards larger chunks. The whole idea is to make your chunking strategy mirror the way people are actually going to use your system.
But listen, picking a strategy off a chart is just the beginning. You can't just guess, you have to test. And I mean rigorously. You need to build what's called a golden data set, a set of questions where you already know the perfect answer. Then you run a scientific experiment. You keep every single part of your RAG system the same, and you only change one variable, the chunking strategy. You swap one out, run your tests, measure the results, then swap in the next one. And you need to measure the right things. Metrics like faithfulness. Is the model's answer actually based on the text you gave it, or is it just hallucinating? And relevancy. Did the answer actually, answer the user's question?
Okay, so finally, let's tackle the elephant in the room. The question that's probably been on your mind this whole time. We have models now with these gigantic million-token context windows. So, do we even need to do any of this anymore? Can't we just dump the entire library into the prompt and call it a day?
Well, the answer is no. And the data on this is surprisingly clear. It turns out, just making the context window bigger and stuffing it with a ton of unfiltered, irrelevant text can actually make your results worse. Performance drops. It's not just about finding a needle in a haystack. The real problem is that you're diluting the model's attention. When it's faced with this massive wall of text, where maybe 99% of it is noise, it can actually lose track of the important bits. This is a real thing, sometimes called the lost in the middle problem.
So this all leads to a really interesting, kind of provocative final thought. Is chunking just a temporary hack? A workaround we came up with because early models had tiny memories? Or is it actually something much more fundamental? Is it a strategic tool for deliberately focusing the model's attention, for curating the perfect context to get a high-quality answer, no matter how big the window gets?
And I think that's the crucial takeaway here. The role of chunking is evolving. It's moving away from being just a technical necessity and becoming a strategic imperative. It's the main lever you get to pull to control the quality, the focus, and the reliability of your AI's answers. It's how you feed the model clean, high-signal, noise-free context. And honestly, that's why truly understanding chunking is and will continue to be the absolute bedrock of building incredible RAG systems.